Hi, my name is Gaurav Sant, and I'm a third generation civil engineer. I'm a professor in the departments of civil and environmental engineering at UCLA, where I'm also the director of the Institute for Carbon Management. On November 9th, 1989, when the Berlin Wall came down, I was 5 years old in India, and so I wasn't really very cognizant of what was going on around me. However, I do have memories of the Berlin Wall because we have friends in India that actually had a piece of the wall encased in a little glass globe in their home. And so I think very much about the Berlin Wall from the basis of those memories. The research that we've been doing at the Institute for Carbon Management is really focused on addressing industrial CO2 emissions, industrial carbon dioxide emissions. And given the fact that these emissions have exceeded 36 billion tons, we produce more CO2 than anything else that's ever been produced by mankind. Now, an important issue that's associated with the carbon challenge, so to speak, is that we emit CO2 in the midst of activities that we absolutely cannot get away from. A really good example is the production of ordinary Portland cement that we use to produce concrete. Cement is the glue in concrete. The production of cement is responsible for nearly about 9% of global CO2 emissions. And what we've been really focused on over the last several years is developing new technological pathways by which we can reduce the amount of CO2 emissions that are associated with cement production. We specifically seek to do this by turning carbon dioxide into limestone. And as someone that grew up right by the beach in India, I explained that, it's all about turning carbon dioxide into seashells, which are also made of limestone. And the reason that we've been focused on this is exactly like we achieve structural cementation in seashells using limestone. You can use limestone that you produce, for example, from flue gas, which contains carbon dioxide, to produce precast concrete construction components and products. A fundamental aspect of what we've really been able to achieve, and I think one of the distinguishing characteristics of CO2 concrete is that the technology was developed to avoid the need for a carbon capture step. Now, as we know, carbon capture is effectively the most complex and the most expensive part of dealing with industrial CO2 emissions. And so being able to develop a process that does not need a carbon capture step, that does not need any purification, transportation, or separation of the CO2, makes for a rather easily scalable process. And this is important because, like we keep emphasizing over and over again, carbon dioxide is not a technical challenge. It's much more an economic challenge, right? So we've really got to make carbon management economically accessible so that we can ensure it without impoverishing the world. And really what the CO2 concrete technology is about is it's about developing small modular but very scalable systems that can be deployed on CO2 emission sites like power plants or cement plants or steel mills anywhere around the world to be able to produce construction products and components that meet exactly the same performance and engineering standards as today's concrete, which cost exactly the same, but they do it at a carbon intensity which is between 50 to 75% lower than state-of-the-art materials. So the way I really think about this, and the reason I think that this work is important is while it's foundationally important to fulfill our climate goals, we have to keep in mind that development is going to continue unabated. So as someone that grew up in India, a developing country, you can imagine that countries like India, countries like China, and all of Africa are going to continue to develop enormously in time to come. There's simply no way for us to say that, we're going to stop and scale back this development because, as an example, the production of cement is associated with a large CO2 footprint. So really where I see our work as having an impact is really being able to permit the necessary and required quality of life improvements that are associated with the ongoing development of cities, the ongoing development of infrastructure, which, as you know, over the last 100 years have led not simply to improvements in our quality of life, but have extended our lifespan as well. All of this is important, especially when we consider the health aspects and the safety aspects that are associated with climate change, as an example. And this is something which is important because, as an example, I can explain this to my daughter and have her understand and have her appreciate that we're doing work here which is important not to simply maintain the world that we live in, but to build a better world for tomorrow. So an important aspect about the portions and the pieces of what remain unaddressed, technologies such as CO2 concrete only address one sector, right? So as an example, we've been very focused on really addressing CO2 emissions from cement production. But this still leaves about 90% of our CO2 emissions that that still remain that need to be addressed. And keeping in mind that, we've got 90% of these emissions to address, while I admit that a large quantity of these emissions, for example, associated with power generation or transportation, will start to go away as we electrify and we use renewable energy, about 30 to 35% of these emissions that are associated with heavy industry are going to still stick around. Why is this important? Heavy industry includes things like glass, things like steel, things like cement, things like plastics and petrochemicals that we simply cannot do without. And so really, we've got to be focused on these what are known as hard to abate sectors. And we're going to need incredibly creative, incredibly innovative solutions that are scalable and economically accessible to address these emissions. I want to point out that, as a child, I was surrounded by civil engineering, right? So an exciting day would involve going with my father to a construction site where I could hang out on an excavator or ride around on a dump truck. So I think in many ways, right from the time that I was a child, I've known I was going to be a civil engineer. And that being the case, I'm really proud to say that I am a third generation civil engineer. And this is important to me because, civil engineers have shaped the world that we live in. They've created our society as we think about it, and they will be a part of the transformation of not only our way of life, but also our society going forward.